to Chapter 8. We're going to be talking more on the repetition structure. We looked at pretest loops in the last chapter. We looked at the while loop. So pretest means that before we enter the loop, we're going to test to see if the condition is true. If it's true, we're going to go in the loop. If it's false, we just skip the loop. And we also looked at the for loop. So the for loop is the one that you know exactly how many times you're going to repeat. And the while loop, you can use it the same way, knowing how many times you're going to repeat, but also if you don't know how many times you're going to repeat, for example, like while the user doesn't enter a -1, then you're going to repeat. So the post-test loop is called a do-while loop in C++. And with this loop, we're going to be actually going into the loop and executing the loop at least once, and then we test at the bottom for the condition. We're also going to look at nested loops, so loops within each other. So a post-test loop can be either a pretest. The repetition instructions can be either pretest or post-test loops. We already went over what a pretest loop was and a post-test loop. And like I said, the post-test loop instructions are always processed at least once. So with the post-test, we go into it once and then we test. With a pretest loop, the instructions may never be processed, meaning that if the very first time you try to go into the loop and it's false, then it's never going to go into the loop. So here is an example of a post-test loop. We say, if you're not directly in front of the fountain, repeat, walk forward one complete step. Repeat while you are not directly in front of the fountain. So if this condition here is true, then we're going to go and we're going to walk forward one time. Then at the bottom of the loop, we're going to test to see if we're not directly in front of the fountain. If this is true statement, then we're going to repeat this loop again, walk. Are we not in front of the mountain? If it's true, we walk. Once we are in front of the fountain, then we stop the loop and div, and we're done. The decision symbol in a flowchart is a diamond, representing a repetition structure and contains the loop condition. Decision symbol appears at the top of a pretest loop, but at the bottom of a post-test loop. So we're going to still use the diamond for this. We're using the diamond for the if statement because it has a condition. We're using the diamond for the while and the do-while loops. So here's an example of a pretest loop algorithm. So with the pretest loop, for this example, let's just read the problem really quickly. We're going to create a program that calculates the commission for each of a company's salesperson. The commission is calculated by multiplying the sales amount by 20%. So this is the one that we looked at, I believe, in the last chapter. So we enter the sales amount for the salesperson. We check, and if the sales is not equal to a -1, that means it's a sales amount of a valid sales amount, or we don't want to stop the loop, then we calculate the commission, display it, ask the user to enter the sales again, and then we repeat it again. So if they enter a sales of -1, then we're done and we stop. But here, if they enter, let's say $1,000, then we go back in and we calculate commissions and display it. Here is how we would do the same thing, except we would do it with a post-test loop. So with the post-test loop, we ask the user to enter the sales amount. We don't check anything, we just go right in and we calculate the commission rate, display the commission, ask again for the sales amount, and then check to see if they've entered a -1. And if they haven't entered a -1, then we repeat. So the problem here is that if the first time that they enter something it's a -1, then it's going to try to calculate and display a commission for -1. But here I guess it's assuming that the first time you'll have a sales amount, at least one sales amount. Something that you could do here is, or in any of the programs, is checking your sales amount. You would want it to be a valid sales amount. So you could put a check in there for that. And we'll talk about that also when we talk about the nested loops. Okay, so let's see how we do this with a do-while loop. This is a different program. All right, so the do-while statement uses the keyword do, then it has a open curly brace, and we put it directly next to the do statement. We don't put it under it. It's just the way that we write it. You could put it under it, but this is the format that we use for C++. Then you have the close curly brace, and right next to it you write the word while. While is a reserved word, just like do. And then in parentheses we put our condition. And with the do while statement you have to use a semicolon. Now for the other loops you cannot use a semicolon. I didn't go over that, but I'll show you that in just a second. So I'm going to go ahead and stop the loop. Stop the show, the presentation, and go over something real quick, and that's the semicolon. So let's look at the do loop first. So let's say we have an integer, and an integer is num1, and we set that equal to 0. So we initialize it. Notice that I did not put a space here between num1 and 0. You don't have to put a space, or you can. Either way it's going to work. Then the next thing we're going to do is do open curly brace, close curly brace, while. I like to do this before I do any coding so that I know that I've included my semicolon and that I've included my parentheses and that I have everything, my curly braces. Then I start typing my condition and then my statements inside. So let's say that I want this loop to keep going while num1 is not equal to 10. And then here we'll ask the user to enter a number, C in the number. Now the thing about this loop is that the nice thing is that you don't have to read twice like the other one. So here you only read once. So we enter the loop, we read, and then we check, and then we read, and then we check. If I wanted to do this with the while loop, it would have to look like this. While, first of all, I'm going to set num1 equal to 0 again. So while num1 is not equal to 10, so I could just leave it where I would say, here, let me just copy this here, make it a little bit faster. So I could do this because num1 is not going to equal to 10 the first time. So, but if I was doing some kind of calculation with the number, then inside the loop, then I would want to do a read before I go inside the loop. And maybe at this point, you know, the user could enter a 10, and I want to check to make sure it's not a 10, and if it is, then maybe I'm doing some kind of calculation here, or maybe I'm accumulating the numbers, so I could say total equals total plus num1. I have to define total. So with a do while loop, you can enter and read and then check, which is pretty nice. With this one, you have to first read outside the loop, then check, then read inside the loop again. So let's go ahead and run both of these. And I'm going to run them separately. So I'm going to comment this out because I just want to test this part right here. This is something that you can also do when you're testing your programs. If you get an error, you're not sure where the error is, just check one little piece at a time of your program to make sure that this piece is working and then this piece is working. So let's go ahead and run this. And oh, I'm missing. So here the problem says cout was not declared in this scope. So the reason cout's not declared is because I did not add using namespace standard. So I'm going to enter number 1, number 2, number 3, number 8, number 9, -1, and then when I enter 10, the loop stops. So that worked fine. Notice here we have a warning, and the warning says used variable total, unused variable total. So it's just giving me a warning that I have this variable here and I'm not using it anywhere because I've commented this out, so it doesn't know that it's being used in here. So now if I comment this part out, and I uncomment this part and run it. Oh, I got these backwards. There we go. Okay, so now I'm going to enter the number 8, 7, oops, and 10. And it stops at 10. And I don't have a warning because I'm using total. Now I didn't see out total, so let's go ahead and see out total just so we can see what the total is. And just make sure that that's working also. So 5, 5, that should be 15. And then when I enter 10, it stops and the total is 15. So I want to make sure too that this 10 does not get inside, doesn't get added to my total. So that means that this has to be in the correct place. If I put this here, right here, then it doesn't add my first 5 and it adds the 10 to my total. So you want to make sure that your accumulator is in the right place. So this is your accumulator. So once again, this is called our post-test loop. We're testing at the bottom of the loop. And then this is our pre-test loop using the while. We test at the top. And one thing that I was talking about earlier was a semicolon. So if I put a semicolon here at the end of the while statement, what's going to happen is the compiler is not going to give you an error, but the compiler is going to think that you're done with the loop here. It ends your statement, and this part just never runs. So if we run it, this is commented out, right? So if we're down here, so I'm going to enter it's going to ask me here, enter a number, C in num1, so I'll enter 5. It should check here, if 5 is not equal to 10, it should go inside and ask me again. But it doesn't. It just stops. So I put 5. It hangs out for a minute. And it stops. So this right here is not allowing it to continue asking me for the information. So no, don't put a semicolon there. Also for for loops, it's going to do the same thing. Don't put the semicolon at the end here. Okay, there is no semicolon for the for loop. It's just for and your curly braces. Same thing for if statement. Don't put any semicolons at the end of if statements. Okay, the if statements are the semicolons are going to go at the end of the C out statements or the C in statements or the assignment statements. Okay. So the programmer must provide a loop condition that evaluates to a Boolean value, so it has to evaluate to true and false. And that condition, again, just like everything else, can contain variables, constants, functions, arithmetic operations, comparison operators, and logical operators. A programmer must also provide statements to be executed when the condition evaluates to true. So inside the do while, you just need to have some statements. And then braces are required around statements if there are more than one. So here's some examples of some do-while loops. In this example, we have we ask the user to enter hours worked, and we see out gross pay equals the hours times 10. And then we ask again for the hours worked. If the hours worked is greater than 0, then we loop. And here they're just pointing out that there's a semicolon here. And this is the updating read. This is the priming read. Same thing here. We have a priming read. We ask them if they want to enter a number. Yes or no. C out number, C in number. Enter another number, yes or no. This doesn't really make sense to use a do while loop here. It's kind of like, let's say you enter no, then it's just going to ask you to enter the number. That doesn't for this I would use the while loop. So here is our program using the do while loop for commission program. So we defined a constant for the commission rate, which is 0.2, which is 20%. Sales amount, they're asking the user to enter as an integer, so no cents. And then the actual commission that they get is going to be a double. We're asking the user to enter the sales amount for the first person and -1 to stop. So the first time, if they enter a -1, it's still going to do this. So again, the do while is not a good loop to use for this kind of program. But let's say that they enter $10,000. It calculates the commission, prints it, and then asks for another sales amount. If the sales amount is a -1, then it stops the loop because the sales amount is equal to -1, so this comes out to be true, and it exits. The next thing we're going to look at is nested repetition structures. So this is a structure inside another structure, like an if inside an if, or a for loop inside a for loop, or a for loop inside a while loop. It can be all kinds of combinations. So we're going to look at the clock program. It simulates a clock with minutes and seconds. The outer loop represents minute. The inner loop, which is nested, represents the seconds. So here we have a for loop, and the for loop goes from 0 to less than 2. This is going to represent the number of minutes. So 2 minutes, or actually, if we start at 0, and then it says, is 0 less than 2? So it does it the first time, and then it goes up to 1. 1 is less than 2. It does it again. It goes up to 2. So yeah, so it's going to do 2 minutes. And so for the first minute, this inner loop here is going to execute from 0 to less than 3. So it's going to actually loop 3 seconds, 0, 1, 2. This loop on the outside is going to go from 0 to less than 2, so 0 and 1. So here's what it's going to output. So the first time that this loop runs, minute's going to be 0 because this is 0. And then seconds inside, it's going to see out 0, 1, and 2. So this here, what you see here, the first 3 lines, is the first time that this loop goes around. And then the second time, when minutes changes to 1, the inner loop again goes 0, 1, 2, 3. I mean 0, 1, 2, sorry. 0, 1, 2, and at 3 it stops, doesn't print the 3. So for every one time that this outer loop executes, the inner one executes or iterates 3 times. This one iterates 1 time, this one iterates 3 times. This one iterates 1 time, this one iterates 3 times. So let's do that over here. Okay, so let's say we have int x, and it could be anything. They use x. I'm going to use I just to be different. We're going to start at 0. You could start at 1. I is less than, let's do less than or equal to 5. So it's going to go from 1 to 5. I plus plus. I plus plus means I equals I plus 1. But we're going to use I plus plus. All right. Then our inner loop, we're going to, let's see, I'm going to copy this. So for the inner loop, I'll define a variable AP. And then inside this loop, I want to see what the value is for I, which is my outer loop, and maybe leave some space, and then P. And all right, so this one's going to run 5 times. This one will run 5 times. Why don't we make the inner one run less? Let's go from 1 to 3. Okay. Now, I didn't, on this example, there's a C out end line here, and I want to show you what happens if I don't put that there, okay? Because it's important to have that. So it's going to, it prints 1, 1, 1, 2, 1, 3. So 1 is this. This is the, for every 1, so when this is 1, when I is 1, P is going to be 1, 2, 3. So let's put our C out end line. That allows us to see it a little bit better. And Del. Oh. All right, so the error says right here, here's where they put the error, but the error is actually here. So a lot of times the error will be at the second line. So it says error expected semicolon before the curly brace. So we just need a semicolon right there. Here we have some warnings, and it's telling us that these variables are not being used, so we're just going to delete them. Okay, so for when this one runs once, this one runs P is 3 times. When I is 2, P runs 3 times. When I is 3, P runs 3 times. And it keeps doing that. This is the outer loop. This is the inner loop. And that's the end of this chapter. So you'll be working, this chapter you'll be working with some nested loops, making sure that you understand how to use those, and also using the while loop.